Let's solve this question from the circles chapter, class 9th. If two intersecting chords of a circle make equal angles with diameter passing through this point of intersection, prove that chords are equal. This is a circle with center as O here. So let's draw two chords here. So it's given that the two chords make equal angles with the diameter passing through the intersection. This is the point of intersection. So it is making equal angles here. That is, this angle is equal to this angle here given. And this is the point P, which is the intersection point. Now let us make a small construction. That is, we will construct here the perpendiculars from center to the chords. This is the perpendicular from center to the chord for chord AB, and for chord CD as well we have to construct. So these are the two perpendiculars here. So now let us solve this question. So we can consider this point as E and this is F. So now we can consider because AB and CD makes equal angle with the diameter, so this also equals here, like angle EPO and angle OPC. So now let us consider two triangles here. So let us consider triangle OEP and triangle OFP. So in these two triangles, so we have PO as common side. PO equals to PO, that is because of common side. We have the angle EPO equals to FPO. EPO equals to angle FPO, because it is given in the question that because the two chords make equal angles with the diameter. Then we have this is 90 degree and this is 90, both the right angles, like angle PEO and PFO, angle PEO and angle PFO, because these are right angles we have done construction, perpendiculars. Then by SAS rule, triangle OEP is congruent to triangle OFP. So we can write then OE equals to OF by the rule of CPCT. Now because we know that the theorem says that equal chords have equal distance from the center. That's why, because OE is equals to EF, that's why the AB is equals to CD. Thank you.